Hello. Hello, good morning dear students. Now today we will see the MOS capacitances. Okay, we know that the capacitance is a thing, or you may say a two conducting plates separated by an insulator have an capacitance. Okay, and if you talk about a gate to channel, is a very important capacitor in case of the MOS transistor. And here what happens, your gate is a polysilicon material. Your gate is a polysilicon material. Below the gate there is an SiO2 layer. SiO2 layer is acting as an insulator, and below that there is a channel. Means at a one side of that insulator, or you may say SiO2 layer, one side of insulator there is a positive, another side is a negative, and it constitute a channel. And there are so many such a places in case of a MOS transistor where such a separation occurs, and because of that there is the existence of capacitance in a MOS transistor. Let us see one by one. Okay, now if you see a dynamic behavior of a MOS transistor, then you will see so many different types of capacitances. Actually, if you see a structure of MOS, these all junctions are reverse bias. And you know that if there is any reverse bias junction, then that reverse bias junction forms a depletion layer, and the depletion layer is acting as an insulator because it is a no charge, means you may say a no charge place. Okay, there where there is a no charge, and if you have anything in between whereas there is a no charge, and one side to that which is being connected to positive, one side another side is connected to negative, then it will constitute a capacitor. And this happens in a MOS transistor between gate and hole transistor, okay, which is called as a gate capacitance. Between gate and the bulk, that is the substrate, then between substrate, see, between source and substrate, bulk is a substrate, between source and substrate, between drain and substrate, between gate and drain, and between gate and source. Means these are the different, and this is a very prominent capacitor. Actually, rest all the capacitor will have somewhat less value, but gate capacitance is already a very you may say a very having larger value as compared to all these remaining. Okay, now you can see that how this happens in a capacitor. See now, when you talk about, actually it is a top view. This is a see here it is written. This is a top view of the capacitor, and this is a cross section of the, sorry, this is a top view of MOS transistor, and this is a cross section of a MOS transistor. And if you see carefully, you will come to know that this is a n region, this is n region, and here there is a thin layer of SiO2. Here it is being shown somewhat larger. Okay, the TOX layer is shown somewhat larger, and above the TOX layer there is a gate oxide. Okay, and this will constitute a capacitor. How it will constitute a capacitor? If you see in the top view, you will come to know that this is a plate. This is a, you may say this is a polysilicon. This is the polysilicon gate, and below that you will see a SiO2 layer, and below that there is a channel, or there is a some part of source, there is a some part of drain. Okay, and that's why there is a gate capacitance, and this gate capacitance is a epsilon 0 upon TOX thickness of the oxide into WL, that is a width into length. This is a simple equation, that is the area. Epsilon A by D, you might have heard this, epsilon A by D. Okay, so epsilon is a epsilon, A is area, that is the W into L. Okay, width into length is the area, and thickness is that is the distance is a TOX. That's why you try to now there will be a different, actually there will be the gate capacitance, there is a capacitance between gate and source, there is a capacitance between gate and drain, and there is a capacitance between gate and substrate, which is the bulk. Okay, here also if you think about, see, this drain is connected to positive, this drain is connected to positive, and this bulk is connected to negative. And because of that, here there will be at this age, there will be the you can say a depletion layer, and here also a capacitance is being constituted, and that capacitance you may call it as uh, a drain to bulk, that is a GCB capacitance. Okay, but these values are less, these values of the capacitances are less, and these values of the capacitances are more. Hence you can see that this is more means gate capacitances have given more importance. Okay, I will show you the table which will tell you that which capacitance is more in case of the different regions. Means if you talk about um, the cutoff region, then definitely there will not be a channel, and because of that there will be the uh, more value is of uh, gate to bulk. Okay, rest to get to source and get to drain having less value. If it is a linear region, this triode means it is called as a linear region. If you talk about a linear region, then the gate to source and gate to drain has a more value. And if you talk about saturation, in saturation definitely the get to source is having a more prominent value. Okay, thank you very much.